Hey guys, welcome back to the DAHKTUBE, and before we get started, if you have topics you'd want me to do, you can comment in the section below and make your suggestions. So today we'll be doing sets. So a set is a collection of items, usually of the same kind. So we usually denote sets by a capital letter. So let's say we have A is equal to the set of vowels in the English alphabet. So we know that vowels are A, E, I, O, and U. However, when we are denoting sets, we usually have them in curly braces or curly brackets. So we separate each item by a comma. And this is the correct way of writing sets. So let's try the set of even numbers between 1 and 9. So we know that even numbers are numbers that can be divided by 2 without leaving a remainder. So let's say we're going to call this set B. So B is equal to, remember your curly brace, and the first even number is 2. Then we have 4, 6, and 8. And that's how you'd write it. If we were to say a flock of sheep or a pack of cards, those are not well-defined sets. A well-defined set is if you would say the vowels in the English alphabet, or even numbers less than 13, or like prime numbers between 5 and 17. So it has to be specific. Okay, so now we're going to do number of elements in a set. So each item in a set is called an element or a member of the set. So for this here, we say 2 is an element of B. So this symbol here means element of. 4 is an element of B. So what if there is an element that is not of this set? Let's say we're going to use 5. So we'd say 5 is not an element of B. For this set B, if you want to find the number of elements in B, we would say n of B, which is the number of elements in B, and that would be equal to 1, 2, 3, 4. So you're basically just counting the number of elements or the number of members in the set. Let's say we want to do this here. Turtle is a member of the set of living things. So we would say turtle is an element of the set of living things. Let's say we want to do Brazil is not an Asian country. Then B would denote Brazil, not an element of an Asian country. So that is how we represent it in set notation. So now we have what you call finite and infinite sets. So let's say we want X to be the number of months in the year. We know that the months are January, February, all the way through December, and we know that there are 12 months in the year. So n of X would be equal to 12. So that is finite because it is countable. But what if I asked you to let Y be equal to all real numbers? That is infinite because you will be counting maybe past infinity and beyond, right? So n of Y is unknown, and this is infinite. So now we have the null or empty set. So the null or empty set contains no element and is denoted by the symbol this here, which is just the empty brackets. So let's say we're going to denote Z as the number of humans older than 300, non-existent. So we would denote it as this symbol here, which is the empty set. We could also denote it as this symbol right here. So now we're going to do universal set. So the universal set is the set of all elements under consideration, and it is usually denoted by a capital U. So for example, we have U is equal to 5 all the way through to 12. So let's say we wanted to denote A based on the universal set. We wanted all the factors of 60. So the factors of 60 based on this universal set here is 5, 6, 10, and 12. So that's basically all there is to universal set. Subset. So if A and B are two sets and all elements of A are in B, then A is a subset of B. And we denote that by saying A subset B. So let's say from this question here, we can see that A is a subset of B because all the elements in A are in B. We can see too that C is not a subset of B. A is not a subset of C. B is not a subset of C. B is not a subset of A. C is not a subset of A. So the only subset we have here is A being a subset of B, because all the elements in A are in B. So let's say we want to calculate the number of subsets in this set here. So the subsets are as follows. So A is a subset by itself, B is a subset by itself, C by itself. Then we can say A, B together, A and C together, B and C together, all three of them combined together is also a subset. And the empty set is always a subset of whatever set we have. So here we can count 1, 2, 3, 4, 5, 6, 7, 8 and realize that the number of subsets for this here is equal to 8. However, what if we had a lot of elements in the set? We wouldn't want to sit and be doing these combinations. So what we usually do, formula here. So subset is equal to 2 raised to the nth power. And n is the number of elements in the set. So a while ago we had 3 elements in the set. So all we needed to do was say 2 to the 3, which we know that 2 times 2 times 2, which is equal to 8. So now we have equal sets. So equal sets have the same or the exact elements. So the order in which the elements are in the set does not matter. So for this example here, we see that A has 15, 16, 17, B has 17, 15, and 16, and C has 3, 4, and 5. Now we want to know which of these sets are equal. Now 15, 15, 16, 17. So it is safe to say that A and B are equal. A is not equal to C because C has different elements. B is also not equal to C because they have different elements. So A is equal to B, A is not equal to C, and B is not equal to C. So now we're going to do equivalent sets. So equivalent sets have the same number of elements. So it doesn't matter what elements are in each of the sets, it just matters the number of elements ought to be the same. So here A has 1, 2, 3 elements, B has 1, 2, 3 elements. That means they're both equivalent. C now has 4 elements, so that means it is not equivalent to A nor B. So n of A, which is the number of elements in A, is equal to the number of elements in B, which is equal to 3. Alright, so in a Venn diagram, we usually use a rectangle to represent the universal set. Inside the rectangle to represent the subsets. So it could look like this. Could look like this. So now we're going to do complement. So let's say we have a set A. here. And the complement of A is denoted by A with this here. So let's say we have U, which is a universal set, is equal to 3, 5, 7. And A is equal to 3, 5. So let's say we have U is equal to 3, 5, 7, which is a universal set. Let's say A is equal to 3, 5. So now A's complement is everything that is not inside of A. So if we correspond these, realize the only thing that is left is the 7. So that means A's complement is 7. So let's say you want to do the intersection of two sets. So if A and B are two sets, then the intersection is whatever is common between both. And we represent the intersection by saying A intersect B. So this here is what we use to denote the intersection. So when we draw the Venn diagram, it looks like this. So let's say this is A, this is B. Here is what you call the intersection. So on this side here is A only, here is B only, and inside is A intersect B. So for A only, which is here, that is saying A intersect B complement. And remember that B complement is everything that is not inside of B. So this is A only. This is A intersect B. This is B only, so it's A complement intersect B. And outside here is A complement intersect B complement, because that is everything that is not inside of A and B. And remember, this is the universal set here. Okay, so let's say we have this question here. So by just looking at A and B, you can tell that the intersection of A and B is 15. So let's say we want to draw the Venn diagram to represent this here. So A would be 12 and 18. That's for A only. So A intersect B would have the 15 inside here. And for B only, we have 13 and 17. Now remember, we have 11, 14, and 16 remaining. So those would go on the outside here. So this is A, this is B, this is the universal. So if you want A intersect B, it would be 15. If you want A only, it would be 12, 18. You want B only, it would be 13 and 17. Okay, now, so let's say we want to do the union of two sets. So it would be all the elements within both sets. So let's say we have A and B. So we represent the union by saying A union B. So this here represents union. So if we wanted to draw a Venn diagram to represent the union, we'd have two circles here. We'd have A and B. And the union would be everything within the circles. With these two sets, it would be A union B. On the outside, it would be A union B complement. So outside would be everything that is not within the union of A and B. And we want to find the union of A and B. So what we would do is, to represent the union, we would have A, B. A, we have 12, 18. The intersection is 15. We have 13 and 17 here. And then we would have 11, 14, 16. So this means that A union B would be equal to 12, 13, 15. And A union B complement will be equal to everything that is not within this, which will be 11, 14, and 16. Okay, so we have a question here. So we have 30 students in a class total. 20 plays cricket, 17 plays basketball, and 7 plays both cricket and basketball. If you realize here, it didn't say 20 plays cricket only. It says 20 plays cricket. Also here, it didn't say 17 play basketball only. It just said 17 plays basketball. So the first thing we're going to do, we're going to say that C is cricket and F is football. So now we have the number of persons in the universal set, which is N, which is the same thing as the number in C union F, which is equal to 30. Alright? Then we have N of C, which is equal to 20 students. We have N of F, which is equal to 17 students. We have N of the intersection, which is equal to 7. So you can basically break it down like this, and then we can do the Venn diagram. So now we have so this is C, this is F. The universal set, which is 30, goes here. So it said that 7 played both, so we know that 7 goes here. Right? The first question asks us to find cricket only. So just by looking at this, we could simply say 20 minus 7, which gives us 13 for cricket only. And then for football, it would be 17 minus 7, which would give us 10. However, if you wanted a more structured approach, if you want N of C only, which is cricket only, it would be N of cricket minus the intersection. We know that N of C is equal to 20, and we know that intersection is equal to 7. So it will be 20 minus 7, which gives you 13 for this here. And if you wanted an approach for F only, it would be N of F minus the intersection of C and F. That would be 17 minus 7, which gives you 10. So now we have another question here. So we have 30 students in total. 21 like English, 12 like French, 6 like neither. So we want to find how many like both English and French. Then we want to find English only and French only. So firstly, we know that the number in the universal is equal to 30. Number in English is equal to 21. Number in French is equal to 12. And the number in neither French nor English is equal to 6. So remember, usually we have this formula here, N of A union B is equal to N of A plus N of B minus. So why we have the intersection subtracted here is because you already double counted it basically in these numbers here. So N of the universal is equal to N of the union of A and B plus N of union A and B complement. So these are some general formulas that you would need to remember. So now what we could do is you could draw up a Venn diagram here. So this is English. This is French. English It didn't say English only, so it means English. So whether they did English and French and English only, it was 21. So if we don't know what the intersection is, we usually label it as an unknown. We're going to call that unknown X, right? So we know that neither English nor French is 6, so that would go outside here. Now, it said English, which was 21, but it didn't say English only. So what we would do is subtract the intersection from this value here. So we have 21 minus X. Same we would do for French, which would have 12 minus X. Now, if we want to do N of E union F plus N of E union F complement. Now, N of E union F is equal to N E plus N F minus N E intersect F. Then we'd have plus N E union F complement. Right? So all we need to do now is fill in. So N of E is 21 minus X. N of F is 12 minus X minus the intersection plus 6. N of U was 30. So now all we would need to do is group like terms and solve for X. So it would be 30 minus 12 minus 21 minus 6. So 30 minus 21 minus 12 minus 6 is equal to minus X plus X minus X. So this would cancel this. So we would have minus X. 30 minus 21 minus 12 minus that would give you minus 9. And remember we would want X to be positive, so we're dividing both sides by -1. So X is equal to 9. So now that we know what X is, that means we know what the intersection is. So the number of students that like both English and French is equal to 9. So now we want to find what is English only. So number of English only, which is equal to 21 minus X. So that's 21 minus 9, which is equal to 12. Then we wanted French only. So that's 12 minus 9, which is equal to 3. So that's basically how you try and deduce what to do in these situations, just by remembering the formulas and how to apply them. So thank you guys for tuning in, and see you guys next time.